Okay, so I think I'm starting every video that way. Sorry about that. I'll try to think of something else to say at the beginning. This video is meant to be a little bit of a motivation for 6.10. So I'm just going to go through a tableau like you see here, and we're going to just take some different sets to be our basis, and they may or may not give us a feasible set. And we're going to look also then at the corresponding solution to the dual. And so when I have this tableau, I can write out the dual constraint, or the dual problem, as you see here. And so given that y is equal to our usual CB transpose B inverse, so given that I know y1 and y2 and y3, I'm going to be able to compute E1 and E2 using these values, right? And so that's how I'll compute the solution to the dual once I have my basis B. So just as an example, suppose I'll just use the current basis that I see sitting here. That is S1, S2, and S3. Okay, so therefore, what is my CB transpose? CB transpose is just the coefficients up here for the S1, S2, S3, which is 0. And so therefore the solution to the dual is just going to be CB transpose B inverse, which is just 0, 0, 0. Okay, so how do I get my E1 and E2 from that? Remember that we had our equations back here, back here. So putting in zeros for y's gives me minus 3 and minus 5 for my e's. Okay, so my y's then were 0, and my excess variables are minus 3. Oh, I had those right there. Minus 3 and minus 5, because I'm putting in 0 for those. Okay, so therefore, I've got these two sets of solutions. This solution is for the primal. This solution is for the dual. And yeah, we're looking at some, we're going to be trying to look at some patterns in our solutions. So you might look at these two sets of solutions just to see if there's a relationship between them. That's an interesting, I see something that might be interesting. Let's continue. You might say also, you might notice also that the solution to the dual is feasible. The solution to the primal is infeasible. Wait a minute. That is opposite. Sorry about that. I see, because this problem over here is feasible, right? We have a BFS for the primal, and the dual is infeasible. So I see that I've even capitalized my error. Okay, sorry. I'll change that before I publish the notes. Okay, let's find a different basis. What if I bring x1 into my basis and I recompute my tableau? What do I get here? This is an interesting tableau. I can pull off the solutions to the dual, CB transpose B inverse, from row 0. So those are 0, 0, 1. And then can I find the solution to the primal from here? Let's see, x1 is 6, x2 is 0, s1 is negative 2, s2 is 12, s3 is 0. Good. And so then plugging in our formula for E1 and E2 again, we see that we get a 0 and a minus 3. Good. And so what do you see about feasibility for both of these now? This is a basic solution for both the primal and the dual. So this is a basic solution for the primal, but it is infeasible because of this minus sign. This is a basic solution for the dual, but it is infeasible because of the negative sign again. Good. So x is not feasible, y is not feasible. Good. But I wonder if we still have a pattern here. I still see a pattern here. Let's see. So what happens if I change the basis again to be x1, x2, and s3? That was really fast, wasn't it? Sorry about that. Okay. So that gives us this dual, which we pull off right here. Oh, I see another typo. I must have been half asleep when I was typing these up. Okay, this should be S1, S2, S3. So this is 3, 5 halves, and 0 for my primal. If I look to E1 and E2, I get zeros for those two. Similarly over here, it looks like X1 is 4, X2 is 6, S1 is 0, S2 is 0, S3 is minus 6. So what do we see here? This point, this basis here gave me a feasible solution for the dual, but infeasible for the primal. Dual is feasible, primal is infeasible. But again, I wonder if there's a relationship here between these two solutions. I think you're starting to see it. Okay, how about another one? In this case, I've got x1, x2, and s1 for my basis. And so that's just using these three. And so using that, I get this for my primal. And so computing E1 and E2, I get zeros again. But this time, notice that I have a nice primal here as well. So what's happening there? Both the primal and the dual are feasible. And so in this case, I'm done. This is giving me an optimal tableau, right? And so this is the optimal solution to the dual. Very good. Is there an interesting pattern in the solutions? Did you notice that? What happens if I take EI times XI? What happens if I multiply these two together and these two together? What do I get? Oop, I gave it away. It is 0. Yes, so SI times YI, S2 times Y2, and S3 times Y3 are also all equal to 0. Good. Let's see if I can see that back here. If I take X1 times E1, I get 0. X2 times E2, I get 0. S1 times Y1, I get 0. And I get 0, and I get 0. Good. So whenever I do those two products, I always get 0. I wonder if this makes sense. Suppose that I've got a slack variable that is positive in constraint J. That means that I'm not using all of the resources I have in constraint J, right? And so therefore, does it make sense that I would want to increase the right hand side of constraint J? No. And so therefore, the shadow price must be 0, right? Because it doesn't matter if I increase the amount I have of constraint J, because I'm not using what I have, right? And so that's why if I take yi times si, it must be equal to 0. So if the slack is not 0, then the shadow price must be 0. Okay. Similarly, we can argue the other way around. If the shadow price is 0, right, what does that say about your equation? That says that if the shadow price is 0, it doesn't matter if you're increasing the right hand side. So therefore, am I saying that right? Let's say that a different way. Suppose the shadow price is greater than 0. What does that mean about the slack? Should the slack be greater than 0? No, because if the shadow price is greater than 0, what that means is that increasing the right hand side, increasing the amount of stuff that you have for constraint J, is actually making a change in your problem. So therefore, do you have excess already in your constraint? No, there shouldn't be any slack at all in the constraint, right? So therefore, if the shadow price is greater than 0, that means the slack must be 0. Okay, think about that. So we could have a similar argument for the dual, and in fact, the idea behind this is section 6.10, something called complementary slackness. We're going to use complementary slackness in order to help us find the solution to either the primal or the dual, given one or the other. Okay, so that's what's up next. I'll try not to say okay right at the beginning of the video. See you then.